go on record. Yeah, I forgot to do recording last time. So, okay. So now go to share screen. Are you all able to see the screen now? Anybody can now see the screen? So okay, so today I think I like to start with last time I kind of spend like 2 hours to do some like prep and just give you some taste of how to do a scientific thinking, how to use numbers, math, some of the simple math you can, a little bit of physics, so you can basically do calculations, can do estimates, and you can get lots of idea in terms of some of our presence in the universe as a individual or as as our whole Earth, and so you have idea, and by dealing with some pretty simple, straightforward principles and numbers, you are able to get at least help you to have better understanding where we are, and all kinds of questions, right? So today because the whole course, the whole purpose is trying to I call it the universe and the life. It's really try to it's pretty broad scope, and anything in principle all comes into under this umbrella. However, I like to start with from something really basic, really, how to say, fundamental. For example, today I'm going to talk about measurement. Basically, I try to, well, when I talk about measurement, I really want to bring you back to the history of human understanding. So basically, how as us as a human or as a Homo sapien, how have we been able to reach to a certain knowledge level, understanding level towards something, right? So this is history of our own intellectual development, our knowledge development, our understanding towards ourselves, or towards anything around us, towards world, towards universe, towards sky, towards stars, towards space, and so on. So here is so here is basically last time I showed you a slide talking about how the initial science was established, right? The science, anybody knows how long our civilization is for our human, roughly our recorded civilization, how long roughly is? Any idea?
10,000 years.
Yeah, roughly 10,000 years. And but 10,000 years ago, we do not really have a way to record our civilization history. Therefore, and maybe you can find something on the on the wall, on the something, but we do not really have like book recording. So therefore, so exactly older than 5,000-6,000 years is really hard to find any systematic records. So really hard, right? We can try to put together a pieces information together and try to understand, but in principle it's really hard because we lost that that time we didn't have a mean to really able to like we are now. We can write on paper, we can save something there on computer or whatever way, deal with information or deal with prior knowledge is really hard. So basically our recorded, really systematic recorded history to a certain degree is really starting from just maybe few hundred BC, which means only about 25 to 3,000 years roughly, right? So we do not have anything even older than that one. Really hard to find any good record or systematic record. So basically, okay. So what happens around 500 to 1,000 before Christianity, before BC, and here's what I'm talking about today. So how how early human understanding toward the world is being established, right? So I talked about before that is lots of a supernatural thing. Is one, there's thunderstorm, there's lightning, there's even sunrise and the sunset and eclipse and all those, and then all the people on the earth's surface feel terribly frightened, right? They thought that is it's God, anything in the sky is God, and we are on the ground, and they have no idea what is really happening, because there's no any reasonable knowledge to base on to make any kind of intellectual thinking or judgment, right? And of course, and lots of fictions, lots of tales, lots of this kind of myths. And so that's why it's all supernatural thing. It's really people think, oh, there's a sun god, there's a earth, and there's a moon god, there's a sun is not happy, that's why there's eclipse, and so on. So okay, here is until about a few hundred years BC, and starting with even before, of course, a little bit before Greek time, ancient Greek time, gradually human society accumulate enough knowledge and courage, and then starting to think, okay, if we don't think everything is really governed by some supernatural thing, what can we think? So here is basically I give you an example. I start with basic, of course, the early science is really about geometry, right? So what do you everybody understand the origin of geometry? Its name we call it 几何. So what is geo? What is
the earth?
Yeah, geo is earth, and metry metry is measurement. So it's geometry is basically is measure earth, right? Measure earth, and actually there's lots of measure sky, because many of the observation is really looking into sky, record the sun position, moon position according to season, according to day of time, night of time, and so on. People has accumulated enough those kind of observation. Of course, but at that time the sky is much clearer than we can see today, and it's really sharp, sky is no pollution at all, and no pollution, neither any of the light pollution like the industry, the city. We have all the lightning on the surface, which really screw up all the light observation. But in the ancient time, they can see the sky so clearly, and they can see clearly the Milky Way, okay, and with naked eye. And I send you some picture of photo of those Milky Way. You can see even on the Earth, some part on top of the mountain, or some really good day, you can certain part of Earth you can clearly see those Milky Way. And so here I give you example. So basically I start with the first question is how we have Earth. We have in the sky have two of the biggest stars. Stars or planet by observation is the sun and the moon, right? So Earth, we are on the Earth, and there's sun and there's moon. And now between those three, that's the first thing any of the ancient people observe and trying to make some reasonable reasoning or deduction. So this is around the 200 BC. This guy, Greek guy, and the first able to measure the Earth. So eventually he was able to get very accurate, very smart estimate about the diameter of how big is Earth. So this one I try to go through the first, and it's basically, of course, before this is is Earth flat? our Earth is round, our Earth is any kind of shape, and those kind of concepts, how this come up. And anyway, so the sequence I try to tell you is basically there's got, even before, even 2,000 years ago, people able to say measure Earth, okay, understand how big Earth is, okay, and of course conclude that Earth is roughly a sphere, okay, and then from there they try to understand how big is the moon, and how far is the moon from Earth, and then try to understand how big is the sun, how far is the sun from Earth. Okay, so even today, looking at all you guys, and I mean myself included, right? We have learned so much about fundamental Western scientific science and humanity, lots of stuff. How many people able to close your book and try to get an idea how we can measure the size of the sun, how far sun is away? Any idea? Who can do that? Can you have a reasonable method able to measure size of sun, then distance from us, size of moon, distance from us, size of Earth, and have any idea? And then think about those people 2,000 years ago. They don't have airplanes, they don't have anything. So how they are able to do that? So that is basically an amazing story about how powerful scientific observation and reasoning, logic, and some simple math is, right? So this is basically the major portion I like to talk about today. I really want you to go back 2,000 years ago, 25 years ago, Plato time, or Socrates time, and Aristotle time, and also this guy's time, and to think about it. If you were that time in ancient Greek, in Rome, and what you can do, try to understand, ask yourself the question, is Earth round or flat? How big Earth is? How big sun is? How big moon is? Of course, look at the sky, we know the sun is round. We know the moon is round. And how do we know the Earth is round? And also talking about the size and the distancing. And how do we know that? Okay, so I will go through this very logically one by one. See, try to trace back to those ancient early scientists, how they conclude that, how they do that. Okay, just very simple math and some observations, and they are able to do that amazingly. Okay, so this guy, we'll talk about it later. So he had made some interesting contribution. So this is around, this is a Plato, Socrates time, about 500 BC. The Greek war and Athens, and of course current Egypt, Alexandria, and Troy, and basically like this is the Greek Empire, the golden age of Athens. Okay, so. And so here is a little bit of history about that time: declines of Athens, the rise of Alexandria, and around couple hundred BC, and Alexandria able to eclipse Athens, become a pretty center of the world of merchant power and the center of the culture. So they build this lighthouse, which amazing history achievement. Is over 100-meter tall, and unfortunately, of course, destroyed and in 1300. But that time they have built a pretty strong, already pretty strong foundation of science around that time, and so now talking about the Earth measurement, and so that's basically the beginning of our scientific thinking for our human society. To people, of course, observe skies, observe, what happened on the Earth's surface, and try to conclude, are there, where are we, and what kind of environment, world we are living in. Okay, and before I start this. And Greek guys already made a very great improvement on understanding of math. So this from the Euclid the elements, and so there are some lots of geometry. They understand the triangle. They understand some relationship, and so here is okay. Of course, this is very simple. Why Earth is not flat, and so if you observe the on the sea surface, observe the further away the shape and whatever, and you can see the bottom disappeared under the water surface. You can see, so it's indicate the surface is definitely not flat, it's curved at least. And when people observe the eclipse, lunar eclipse, they can see the shadow of Earth. And so they understand the Earth is more likely a sphere, right? Because the curvature of the eclipse from the shadow of Earth, they roughly know. Okay, and okay, so basically here is the earliest method using by this Eratosthenes, this guy, about 150 years before BC. And so he was able to scientifically or mathematically deduct and deduce the size of Earth, actually with about 1 to 3% of accuracy, amazingly accurate. So what he did is he found a small place, a city called Seni. Seni is about, he actually sent a group of people to measure the distance from the Alexandria. And it actually is about 800 kilometers away, south of Alexandria. Okay, so he knows the surface distance between those two cities. And he one time he noticed that there's deep well in this city, Seni. And at a particular day of the year, this is very deep, narrow well. People is able to see, the light is able to reach the bottom of the deep well to see the water surface. But the other time, it's dark, you cannot see the bottom because the light couldn't be reach vertically to the bottom. So he understands now the sunlight on that particular day, on that particular location, is going down vertically to the surface. That's why he's able to see the very narrow, deep well and see the water down there. Got it? Okay. So that is one piece of information. And he also realized on that same day, a person in Alexandria, which is 800 kilometers away north, and they put a stick on the ground, and there's a shadow. So basically, in Seni, if you put a stick on the ground, there's no shadow, right? Because it's a basic vertical. So, but on Alexandria, Alexandria is able to see that shadow a little bit. So he's able to measure that shadow, from that shadow, able to measure the angle of sunlight to that vertical, perpendicular to surface, Earth surface stick. So that angle is actually measured to be roughly 7 point some degrees, 7.5, let's say. Actually, I think that time he measured 7.2, whatever. About 7.5 degree. Okay, now if you look at it, if you treat the Earth as a sphere like this, you put this cross section and you realize, there's a 7.5 degree, this basically this pi angle, and then you know that on the surface that is about 800 kilometers. So therefore you are basically doing a 360 divided by 7.5 and make the whole circle, then time 800 kilometers. That end up with the circumference of the Earth, the size of Earth. So that came out to be pretty That's a mouse schema and another drawing, and another drawing. Okay, understand? Okay, and so that came out to be about where we are today. Okay, that's 1% from basically that's 1% accuracy of. Actually, of course, if he used 7.2 degrees, that will be roughly 4% of error. But it's extremely, that is over 2,200 years ago, and very 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 accurate. So even today's regular human, if you don't have a really fancy scientific method and tools, you won't be able to get that number even, right? So how accurate? So that is one initial. So that's the first time in our human history we were able to give a reasonable estimate of the size of the planet we step on, right? So that is here. Okay. Any question? Anyone? Everybody understand? So let me see if anybody missed. If they still can you see anybody want to come in? Let me see. Yeah. Anyway, let me see if let me stop sharing. Let me check if anybody is coming in. Oh, nobody. Okay. So we are all in. Okay. No more. Okay. So let's go back to here. So you get it? Anyone has a question about this? Anyone? If you like, you can join and try to get an idea what it really mean. And this is simple geometry basically. After you are able to get the input from there, right? Is it okay?
So was his like calculation or like theory like very accepted at that time?
Leo, I cannot hear you clear. Can you speak louder?
How about now?
Yeah, good. So what's your question?
Oh, I was just asking, was his like calculation like generally accepted at that time, or it was like just disdained?
Oh, you mean there was no understanding that time? I mean, even remember the true human society as a society and able to say established ND I need to upgrade too. I think last time somehow they allow us to go 2 hours without needing to upgrade. So otherwise I have to re-come back. Anyway, so I think we are already 30 minutes into the meeting. I think they're set 45 minutes, 40 minutes of the if I lost you, you just go back and I will relog in. I will update. I need to update my Zoom account. So yeah, at that time, 2,000 years ago, there was no even clear understanding sun orbiting Earth or Earth orbiting sun. Remember, the sun center theory is only established roughly in 1500, 1600. After that's another 1800 years later compared to whatever this guy did that time. You know what I mean?
So like he doesn't necessarily understand where the sunlight is coming from or understand how eclipses are happening, but he's able to figure it out by doing the math and using these observations. Right. He put this way, he was the outlier. He believed, he already know. Let me go back. He already understand. I think he already understand. So he already know that Earth is round. He already know that I believe that time there's people believe already like Earth is not the center of the universe. And however, there was no common because of religion reason, whatever. There was no common understanding on that. There's just some small group people
with that kind of understanding. Okay.
Wait, so let's suppose like he sort of like published that kind of understanding or like told other people about it. Did other
There is,
people...
of course, there is a record. Otherwise, we won't be able to trace back to this understanding. But apparently, that one wasn't really well received by majority people. That's why it take another over 1,500 years before people starting to really the second round of scientific understanding. That is basically go to the Galileo time and later. So that is, Copernicus and Galileo time and, Kepler that time. That is, again, that is rebuild the whole understanding. But
obviously it's like the same sort of like, it's the same science understanding, but it's
right, absolutely. Actually, if you look at if I look at, just give me a second. I think last time I showed you. So basically here is this picture showing the capture at that time, what kind of understanding those people is. For example, Pythagoras already believed about 500 BC that Earth itself is a sphere, right? So that is, and then there's, of course, then there's go back and forth. Aristotle and about 300 BC, still go back to Earth-centered universe, and there's quite that time still very chaos in terms of understanding. There's some people, amazingly had some huge deep understanding, but wasn't really accepted by the majority people. So that's why there's still theoretical understanding of the world. Even like about 100 AD, and there's a famous of the Earth-centered model, and still that time was public accepted model, right? Until 1600, and then basically and able to prove as Earth is not the center of the whatever universe. So
humans are trying to prove the same thing throughout thousands of years.
Yes, through thousands of years, trying to nail down a common understanding what kind of system of the Earth.
It's just like Black people are protesting the same thing as they did 60 years ago.
Yeah, exactly. Yeah. So you can call it a stupidity of the human as group, or you can call there some really smart people as geniusly smart someone. But,
well, it depends on the historical context, though. Like,
right, exactly.
If genius like Alexandra couldn't like successfully persuaded his sort of like the people around him that
at that time, because there's remember before science is religion, so religion was dominant. The supernature thing was dominant when initially, right? So that is the church has very powerful. That's why Copernicus, someone was burned to even at 1500 burned to death when they try to propagate this a sun-centered theory on Earth is not centered. So that there were lots of challenge, lots of barriers they have to overcome before even somebody able to figure out something, and it's turning that into a common understanding and knowledge is a big hurdle. That's why it lasts over thousands of years, across. Got it?
Sometimes the Greeks come up with an idea without like an actual observation to prove it. Like I think some of these, like at least one of these things that they came up with was by complete chance. It's from on the graph from 470 to 380 BC, Democritus proposed that the world is built from individual atoms. The way he came up with this whole thing was, he said, well, if you can cut something infinitely, then things will just disappear because you will cut so much that they don't exist anymore. And that's not how we prove the existence of an atom. So sometimes it's like, chance. And we're lucky that like later on when people thought about like things that they see, they thought of, oh, Democritus said something about atoms and proportions and them combining to form things, and we actually got modern science.
Right, exactly. And but it's always interesting to look that way into the history, saying, you know, how when we are able to really make a revolutionary understanding towards sense, what kind of challenge it face, and how long that could take for us to overcome that kind of barrier. And you know, that says a lot about you know, a lot of things. It says a lot about the power of religion. Says lots about, you know, what majority of people may believe or may not believe. You know, I'm willing to believe. And it's anyway. Okay, so that is now we get an idea of size of the Earth. Okay, got it. And now I'm going to move forward next, and is basically now we have an idea of the Earth size. Now the question is how. Now the next, how about the moon? How about our distance to moon? How can we get that? And our distance to sun? Okay. So now the next question actually came out is basically also roughly same time or a little bit later, is people able to deduce the size of moon. Is the moon bigger than sun, bigger than Earth, or smaller? How do we know? We already know the diameter of Earth based on this method, roughly. And how do we know the size of moon? Any idea? How can we know the moon size if we know the size of Earth?
Maybe like the eclipses?
Yes, that's true. That's eclipse. So, okay. So now that's next. So here, so eclipse. So when the full lunar eclipse, basically that happens when Earth blocks the light between sun and the moon. So sun will fall into this shadow of Earth, and so that is the, you know, the moon is completely eclipsed. Okay, so from here, and those smart thinkers able to derive the size of how the relationship between Earth and the moon. Okay, so it's basically is like this. So the thinking is, and you know, remember moon is also able to